Alright, this is my third attempt at this, so bear with me. I'm using Cam Studio, which is open source software. So what I'm going to have to do is I'm going to have to talk a little bit faster than I normally do, get through this. Some of the other videos, the videos from class did not save correctly either, so I'm trying this a different way. So let me begin. My name is Josh Pearson, and I'll be your instructor for the next semester. And this is Engineering Your Future with Engineering Young Engineers of Today. Do you like to take things apart? Do you like to take CD players apart, or you don't know CD players, computers apart, stuff like that? Would you like to find building a game more fun than playing a game? Curious about robots, how to solder, epoxy, build things, cut saw, your usual use saws, build buildings, build catapults, trebuchets, whatever. Enjoy math or science. Read science fiction or fantasy. Well then, welcome. You are amongst friends. Engineers, we learn by doing. You will work with your head and your hands. Become a technology creator and not just a consumer of technology. Uh, how our classes are going to work: 1 hour labs twice a week. There's going to be no homework, no tests, even though sometimes I might ask y'all to try to do some stuff outside of class. We are going to be creating a digital portfolio using HTML and Google Sites, a power source. No, we're not going to be doing electric tree. We are going to be doing a lot of programming using Spark Funds and VenderKit. This is where the electronics and the programmer to come hand in hand. And we're not going to be doing that now, but we probably will be talking about quadcopters, model airplanes, stuff like that. Hopefully all y'all should have a Gmail account. So aptitudes, what does it take to be an engineer? You have to have, put these 3 skills up there. Math, science, and the problem solver. Now the math and science do make your problem solver. Get to pretty much the bare minimum in engineering. It's like calculus 3. Alright, so you have to get up there. You don't have to be an expert at math, but you do have to understand what's going on. So if you see an integral sign, you don't freak out. You should at least understand what's going on with that. And same thing with the science part of it. You might not have to know every single equation, but you do have to know what science is. And we'll talk a little bit more about that later on. And you have to be a problem solver. Problem solvers, the math and science will make you that problem solver. Getting up to the calculus 3 and all that other stuff makes you a problem solver. You have to have perseverance. You have to be able to sit there and work on a problem for hours upon hours if you have to. You have to be a team player, and you have to learn how to communicate. Webster's dictionary defines the practical application of science math as in design and construction of machines, vehicles, structures, roads, and systems. Half of the jobs created today are a result of technology. I don't really like that expression because even a steel plow in a field is a result of technology. It does make more sense when you throw in the next part of it, however many jobs are being lost to technology. This is a chart showing how the job market is changing. The low skilled jobs are pretty much staying the same. The medium skilled jobs are actually decreasing while the high skilled jobs are increasing. Well, what are these high skilled jobs? These are the engineers. Alright, these are the people building the robots that take other people's jobs. I hate to say it like that way, but it's just the way it is. The medium skilled jobs are the ones that are declining because those are factory workers and stuff like that, which we see here in this factory, which is a razor making factory way back, or Gillette I think it is, or somewhere. There's about 3 people in this shot, 3 people total, and an assembly line full of robots. At one point in time, every single one of those robots was a person. So you see that the high skilled jobs are the ones building the robots, medium skilled jobs are the ones getting replaced. So a lot of people want to know incentives. Well, engineering has a great financial incentive, but if you get into it for the money, you will probably fail. Alright, you gotta get in because you love this and you want to actually be able to make stuff and build things and stuff like that. But this is the top 10 college majors that lead to high salaries. This is not the top 10 out of engineering and science. This is the top 10 overall. It just happens to be that engineering is in the engineering and science are in the, and math, you see applied mathematics are in there, are the top 10. Scientific method, let me just kind of, again, I gotta save time here, so. Alright, observation. This is the scientific method. A guy named Edward Hubble made an observation that the universe is actually or had a hypothesis that the universe is getting closer together. So at one point, which has actually made sense at the time because of gravity. No matter who you are, where you're listening to me from on the planet Earth, or even in the universe, if you're listening to my voice, you and I have some type of gravitational force between us. We are somewhat attracted to each other. And it is sometimes very, very, very small, but it's there. So the theory was that the universe should be coming in closer together. So he did an experiment. Edwin Hubble looked through his telescope. He analyzed the data. He reached the conclusion that he was dead wrong. The universe is actually accelerating away from each other. So this actually led to the point of this led to the theory of dark matter and dark energy, and of course the Big Bang. Peer review. Peer review is an important part of the scientific method because if somebody can prove you wrong, they will. All right. So if you put a paper out there for whatever, and there's some cockamamie thing, whatnot, somebody can prove you wrong. They're going to do it. All right. It's not all the scientists in the world are not out to get us or you or anybody else. If they can prove somebody wrong or another scientist wrong, they will. Scientists investigate that which it already has. Engineers create that which has never been. The engineering method. I'm gonna kind of again trying to save time here, so bear with me. All right, research. When you're doing a engineering project, research, and when you're done researching, research more, and then right before you go to bed, research again. Plan. You gotta plan out what you're gonna do. You have to build. Actually, I'm gonna go back up. You have to go to prototypes. You have to build this prototype. You have to test the prototype, realize it doesn't work, slap it around with a hammer, maybe even set it on fire, then repeat the entire process. And then you have to go to production. So the difference between the engineering side and the scientific side is the marketplace. Engineers have to worry about what the marketplace is. Types of engineering, there's chemical engineering, electrical engineering. So if you're interested in renewable resources, those might be the two fields to go into. Civil engineering deals with the road construction, bridge constructions, power plants, pretty much the things you don't really think about when you're driving, when you're in this modern technological society that we're in. Civil engineers are the ones responsible or help us out with that. Electrical engineering, of course, is power generation. Geotechnical or environmental science, that's actually a really cool field, or environmental engineering, really cool field to get into. And then there's mechanical. Mechanical engineering is the aerospace, that's your rockets, your automotive, your cars, your biomedical, your prosthetic limbs, your mechanical engineering. Not sure why that's in there twice. And naval engineering, so if you want to build weapons and stuff like that, that might be a field to go into. Here is the top 10 list, or a list of aptitudes that employers look for. You can see that communication skills, teamwork skills, and interpersonal skills are on the top 3. You have to have a strong work ethic, but if you make it through engineering school, you already have that strong work ethic. Self-confidence, leadership skills. You have to have leadership skills because you probably will end up having people under you. After your first job, your GPA doesn't really matter that much, but so I need to save time, so I'm going to stop right now.